Bet, par Baltijas ugunsdrošības laboratoriju. Runā, ka tā ir viena vieta, uz kurienu cilvēki dodas svētceļojumos pilnīgi, tīpaši drošībnieki. Jo šeit ikdienā notiek tādas iespējīgas simulācijas. Dažādās telpās tiek iniciēti ugunsgrēki virtuāli. Ne tikai virtuāli, bet arī praktiski, dabiski, reāli, kurus mēģina lokalizēt pēc iespējas efektīvāk ar dažādiem dzēšanas līdzekļiem, visu, ko var izmēģināt. Gan scenārijus, gan līdzekļus, gan situācijas, lokācijas. Var paredzēt un likvidēt pilna mēroga ugunsgrēku birojā, lidmašīnā, noliktavā vai jebkur citur. Vai tas ir iespējams? Par to tēmā pilna mēroga ugunsgrēka testēšana, veids, kā izprast sistēmas darbību pirms ugunsgrēka izcelšanās. Šodien šeit runā Baltijas ugunsdrošības laboratorijas direktors Bogdan Raciega. Bogdan, welcome to the stage. Finally, you're here. Great to have you. Thank you and good luck.
Thank you very much.
Hey, kā mums ar aplausiem? Paldies!
Hello and welcome. It's great to have you here. You are a really important audience because we are staying up to this hour. And it's really fantastic that this part of the fire was already added to the agenda of this security conference. So today I will speak a little about the active fire protection system testing in our laboratory located in Gdańsk, Poland. It's quite a brand new laboratory. We are on the market like 2-3 years approximately. So I try to introduce you to this what daily we are doing. There will be many of the videos. So with these videos I would like to show you how it looks, the dynamic of the fire tests, why it's important to have this kind of facility to just assess that the active fire protection system are working very well. In this, the most important point when the fire occur in the building. So starting from the first slide, this is the biggest project which we performed last year. It's full-scale aircraft, 12-meter long, 12-meter wide, and 6-meter height. It was for the active fire protection system testing for the aircraft hangars. Because of the eco-friendly solutions, we testing the water mist system for the aircraft hangar protection, where before the foam system mainly was installed in such hangars. So the agenda of my presentation is on the beginning just to understood why the need of the active fire protection system, especially this part of the Europe, is important, because there is not so much laboratories which are dealing with such things. This is the specific active fire protection laboratory, and there's plenty of the passive fire protection, like for the testing of the walls, windows. We are testing purely active fire protection system like the sprinklers, clean agents, water mist. It means the active system which working in case of the fire. Then there will be many of the case studies which will show you how this will work. So the main goal to build the laboratory in this part of the Europe was that there is not yet such laboratory in this part. There is few laboratories in Scandinavia, but we was forced to build this laboratory because there was a kind of hole in the market, especially in this region. So we are in Poland, close to the Gdańsk, 20 kilometers from the main city, and the laboratory is set strategically 15 minutes almost from the Gdańsk airport, so our customers are reaching us very well. And then we have access to the Gdynia and the Gdańsk port. Why? Because for our testing we are using plenty of the materials which we need to source from Sweden, from US, from Norway. So the logistic with this kind of fire testing is extreme. So our facility looks like on this slide. We have currently the office building, storage building, where is the special conditioning for our materials, and then we have a laboratory hall. The unique of this laboratory hall is that we have two movable ceilings, each 10 tons, each 22 multiplied 11 meters. So in total we can test 9,500 cubic meters for the one go in the active fire protection system. Then we have a plenty of this transfer work between the materials for the fire testing, and there is a lot of preparation. So this is the back of the laboratory, looks like that with the cleaning system. Because of the impact for the environment, we are cleaning all these gases from the production during the fire test, because there is many of the smoke in this kind of testing. The laboratory floor area is 634 meters and the 15-meter height. And why this laboratory required ISO 7025 accreditation? So the ISO 7025 accreditation is a kind of passport ticket for your results, for your system, that you can go wherever on the world with this, and the data from this fire test will be accepted. So this is unique and the first information that you should get to go forward with the results from these tests. Then what is exactly the accreditation? So in short words, it is something that you have the competence, you was verified that you are able to perform such testing. Then there is accreditation that allow you to perform the fire test according to the specific standard like the FM Global, VDS, EN. Then you must get additional acceptance from the third-party bodies like the VDS, US Coast Guard, which we have. And this is how it looks the typical day in the active fire protection laboratory. Here is a picture of the turbine enclosure where we simulate 8 fire which may occur on the turbine enclosure. This is the 2300 turbine enclosure from the Mitsubishi gas turbine, which is the biggest on the world. And here we are simulating just the leak on the injector with the 150 bar of the diesel. And this flame is ignited by our firefighters, and then we launch the suppression system, which in this case is a water mist system. So the case study, first the case study which is really connected with the big fire in Poland is Archive. So we built a full-scale model of the Archive. We proposed how this fire test should be executed. We installed the thermocouples, we developed the program for the fire tests, and then we go into the fire. So from our laboratory, you see now the view from the 4 cameras, 2 cameras, which are just showing exactly on the left what is going on, and the 2 cameras which are the thermal cameras. After the 10 minutes, there is nothing to see on the left cameras. And now we are igniting, simulating the fire in the archives. There is the wood creep with the 50 millimeters of the heptane to ignite these books, because there was approximately in all the tests burned out 12 tons of the books. Those are the real books in the boxes. And now there's the activation of the water-based system, the high-pressure water mist system. On the right you can see what is happening, and the test was terminated after 30 minutes. So we analyze the damages and the temperatures. And now the firefighters are arriving, and you can see on the ceiling that there is a lot of heat. So this is a good way to keep still, even in the firefighting operation, active fire protection system on, because then the ceiling is cooled down with this system. And then we are arriving to the question, is the knowledge power? So unfortunately, with the main school of the fire in the Warsaw, we had a project about the Archive fire protection in 2020. And then in the February 2021, there was a big fire in the Krakow Archive. And it was a purely example of the knowledge not used on time. And Krakow Archive fire fact. So there was the fire in the archive which take 6 days with the flames and 6 days just to put off the fire after this what happened inside. On the end, there was the fire protection system, active fire protection system, which should never be installed there. There was unfortunately not proper system installed there. I cannot say what was the system because the court case is still ongoing, but there was not a water-based system as I show you, which we test 6 months before. Firefighting action was really extreme because it was in the February. On the day was 1 Celsius, on the night was like 8 Celsius. So the firefighters was frozen. They was fighting 12 days with this fire in Krakow. This is the view of the archive building. 2 archives was completely lost. 2 archives was saved because of the passive fire protection, which isolate this fire. There was the heavy construction machines used to just make a holes and save this building. In this kind of archives, there's a specific rules that there is limited access inside. So the chief of the fire safety brigade do not decide because of the risk to send the firefighters inside. It was too late already. The next case study is a data center full-scale fire test. So for one of the company, we perform the full-scale fire test according to FM Global Standard 5560 Appendix M and Appendix N. Laboratory provided 3D model for this kind of mock-up. We built one-to-one this mock-up in our laboratory. And then this mock-up was equipped with the 12 fans and the cables. The cables are exactly the same like are installed in the data centers. The cables was sent to the FM Global to US for the validation if the cables are fine for the fire tests. Within 3 months of this fire test, we burned out 230 kilometers of the cable. So it was a plenty of the material. The fire with the cables is extremely hard. You cannot imagine how difficult it is to put the fire out. And this, what we observe here, it's a fire for the upper part of the data center. Then the data center can be equipped with the below floor cable trays, which will be on the next part of the video. You will see the mock-up. This is the below floor, so you are walking on this area which is on the top and the cable trays are below. It's approximately 1 meter height area with the cable trays, and the flames in our laboratory from this cable trays was 5-6 meter high. It was extreme fire, and then the system based on the bulb nozzles, the water mist again, was activated with the certain time because of the temperature 68 Celsius. The most challenging part of this fire test was the constant ventilation, because in the data center for the cooling purposes you have the ventilation which is constantly blowing to cool down the servers. It means that this ventilation is cooling the bulb which is installed in the sprinkler nozzles in the water mist nozzle. So where we had 68 Celsius bulb, we get activation when the thermocouples close to the nozzle was 125 Celsius. 2 times more. So now you can imagine how difficult it's activate the system in the fire test. Then this big project which we had, it was the aircraft hangar for our customer from the Switzerland. So because there are not clear rules for the performance-based system in the hangars, there is an FPA 409 chapter 5 which telling you that you can use for the aircraft hangars the performance-based system, but you need to develop the test standard. So to develop the test standard as we had 4 months of the development, the standard, we involve 7 bodies. So starting from the fire consultants, system manufacturer, then fire laboratory, hangar owner, aircraft manufacturer, insurance company, and the AHJ, which is authority having jurisdiction in this project. So what is happening in this hangar and why the water mist is as a water-based system quite good? Because we are able to cover not only the hangar, but the same with the office with the same system. And what the insurance company love currently is that when you have the fire case on one aircraft, you are able to save all the aircrafts which are in the hangar after the release of the water. There was the situation which we know from the same insurance when after the activation of the foam system, the manufacturer of the aircraft, which was not in the fire, was stated as a total loss. So you can imagine that in one false activation of the foam system, you can lose the 16 aircrafts. This was in the one project. I cannot say that it for all foam system in the aircraft hangars, because this is only our experience in this project. Then we have as a laboratory, the YouTube channel. For our audience, we try to communicate with the videos. Of course, those videos are commercial videos with not many details, because we have NDA with our customers. But here is just the information how we are working and how difficult it is to prepare such fire tests, which never did on the world yet. So here there was the mock-up of the aircraft built in our laboratory. We burned out in one test 300 liters of the Jet A1 fuel. This ignition was with the additive of the heptane. You can imagine that the Jet A1 fuel is so safe that we are not able to ignite the pool fire with this stick. So it's not like in the TV, like the Jet A1 fire in the pool is able to be ignited. It's not, because it's just designed to be safe. And there was the water mist system on the ceiling and on the floor. It's important to stop the propagation of the fire to the next objects. We have a 4 thermocouples tree from 0 to 12 meters, because the ceiling was set on the 12 meters, to observe if there is any 100 Celsius around the aircraft, because there was the limitation from the insurance that the fire cannot spread to the next aircraft. 5 meters from the center of the fire cannot be more than 100 Celsius. Now we open the door, and then there was the cleaning system, which just sucking all these gases to our cleaning system. So few views from our fire tests, which are coming after the test report. It's a time of the ignition, time where we have 60 seconds for the pre-burn without the system, and the time of the activation of the system. We have a special witness portal in our laboratory, so our customer can sitting even in the US and be in live with our cameras during the fire test. We have the thermo cameras, as you can see as well on this view. If there is something that we can do more from this kind of tests, which are expensive tests, so we did the 3D scan of our laboratory inside, where already the aircraft was there. Why we did like that? Because there was the more customers for this project who asked us for the CFD simulation before, just to burn the complete aircraft. So we combine this digital reality with the data from the CFD, and before, when we go for the next test, we are providing the CFD based on this 3D data to our customers. They are able to optimize the system even without any fire yet in our laboratory. Then, despite the water-based system, we are testing the clean agent system. I always showing this to the insurance companies, to the designers who are arriving to our laboratory, because we are performing the trainings as well from the active fire protection system. This is the typical setup for the clean agent system testing, and everything is done by our technicians. We are doing welding works, pipe works, everything alone. And there is a short relation from our tests with the clean agent system. 4 fire tests was performed to prove that the system is working well. This test is a kind of confirmation for the concentration. There was the 12 heptane cans. This is the discharge of the system for the clean agent. Its requirement to discharge the system within 10 seconds. And there are the benefits and disadvantages of this 10 seconds. There is, in the test number 4, which you will see soon, the big overpressure in the enclosure. And the designers were deciding to make the system clean agent or the CO2 should assume that there will be overpressure inside during the discharge. And especially in this test, which was the most difficult one, because we had the openings before the launching the system, because you have to maintain 20% of the oxygen before the release of the system. When we close all the openings and now it's a system release, we observe on the enclosure plus 250 Pascal overpressure, and within milliseconds minus 250 pascals. In one of the tests we damaged completely the enclosure because of this effect. So to make this test you can see the cameras and the whole wall of the enclosure that it's just working. So if someone is taking seriously this overpressure when using the gas system, they should. But in the marketing materials you do not see this effect because this is just disadvantages of the system. So all the system has advantages and disadvantages, and we need to, as a laboratory, just be open to our audience and tell how this is working. And then this is the view after the test. So you've seen some rust, and I will leave you for the decision as well, because I do not want to be against the clean agent manufacturers, but this is our observation only. And if there is any rust in the marketing materials, I don't think so. Then what we already found that the data sheets are not exactly telling this what was happening during our tests. So there is the overpressure, there is a kind of shock, thermal shock in this test as well, plus these marketing materials which we had was not exactly the same like we test based on the results. And then what is something which is terrifying now for all, there are the EV fires. So we are doing this year a lot of car park fires, and you've seen this fire close to the Netherlands, and on the beginning, in the first hours, it's EV. No, it was not even EV car touched by the fire. There was just fire from the standard IC car, it means internal combustion engine car. But the problem is that even if you have a great system, always you must assume in the risk analysis that there can be a human error. And there was, in this case, human error, because after the discharge of the CO2 system to the area where was the fire, the crew lost one crew member, and they was looking for this crew member who after was found died, and they opened the area after the CO2 discharge. Based on the laboratory where we are testing CO2 system, after 15 minutes of the discharge, you are not allowed to unseal the enclosure. So they just lead the system to be unable to work properly. And this was the thing which led to this disaster. So what we are testing for the RoRo, because the marine industry is a big part of our job, so those are the tests for the RoRo decks. It's an IMO 11, IMO 1430. This is the mock-up of the car with the 12 pallets. Again, we are doing the videos from our tests, how we are performing these tests. And imagine that there was a project in the 90s year when the laboratory from the Sweden burned a lot of cars to convert this car to the fire model, which is the 12 pallets with the 14% moisture. And believe me, this fire is extreme big. With the 2.5 meter ceiling only, we have 350 Celsius on the ceiling when the suppression system, as you can see here, the water mist, high pressure water mist in this case, was released. And the fire job in this case, the firefighting system job in this case is just to stop the propagation of the fire. It was for the marine tested, and this kind of installation you can see on the RoRo decks. The problem is that still not this installation with the water-based system are installed. That's why we have this kind of problems with the fire like in the television. We are doing a lot of tests for the car park garages, as you mentioned, so it's important to know that there are the standards for the fire protection for the car park garages. You've seen a sprinkler system, you've seen the car park garages, the water mist systems, and what is important to understand that there are the fire scenarios, 2 fire scenarios with the sprinkler nozzle above the car and below under 1 and under 4. It means under 1 is just above the car and under 4 is just as a cross diagonal between the cars. So the real situation which you can see in the car parks are on the left, like scenario under 1, when the sprinkler is exactly waiting for the fire which is from the car, and then you have the sprinkler which is between the 2 cars, and you need to predict that someone will standing like this nice car on the right, and this fire needs to be succeed with these systems. That's why there are the scenarios with the most worst case for the firefighting system tested in the full scale. So if the full-scale fire tests are safe, there is a kind of nice video which we did from one of our fire tests with the water-based system as well. So after this, what happened, I will explain you. So it was the activation of the water mist system in the condition where there was the 4 square meter pan with the diesel already in fire. So within 120 seconds there was the heating of the room, and because of the water mist activation there was already the overpressure. So yes, the fire tests are safe if the people who are performing this fire tests are well trained and can predict what is happening. Maybe you've seen that this where the video was recorded was from the evacuation door, because we already predict that there will be the overpressure there. So it's important to arrive to the laboratory who can predict what is happening in the fire test hall. So the laboratory is to find the situation where the system is going to fail the tests and is going to find the best optimum system which is able to pass the test. So there was the situation where we found that the system is not able to handle the fire and the test was failure. But in this case, we need to stop somehow this fire. So we have the fire brigade group. I have 4 technicians, which are the firefighter, and in case of the serious fire, we are inviting as well on the contracts the 4 firefighters from the Gdańsk Fire Brigade, the professional firefighters, which are working with us. So the need of these full-scale fire tests, especially in the very dynamic times where we are living for the fires with the EV cars, are just to use our facility to understand what may happen where you have this kind of fires, which before was not yet known. Like the EV cars are not from 30 years or maybe from the 15 years. So there are the new risks which need to be addressed. And now, this year especially, we are working a lot with the EV cars. We have already the talks with the Volkswagen Wolfsburg, where they give us brand new cars, EV, for the just put them in the fire and test the suppression system. If some of you are interested, you have my contacts on the last slide, so please be in contact with me. I will be happy to reply to all. I think it was everything. I have 1 minute before. If there are any questions, it will be really great to reply to these questions. And this is all. And the last presentation, daily, maybe I will look like on this picture, not with the suits, but this is the work how we do. Thank you very much. It was a pleasure.
Yeah. So I wonder, what was your childhood dream you would like to become? Who?
Firefighter from the first date, but nowadays I'm aeronist, because we just ignite the fire and making troubles for the firefighting system to make this system safe.
Right, yeah, it is a great goal to have, although if some parents would ask some kids working on this facility what they do for living, it would be burning.
Yes, exactly. That's why this is the big benefit to work with us, especially.
So where do all the burnt waste goes?
Okay, so we have the companies who are taking over from us all these wastes, if those are like the wooden pallets or something like that. The wastewater, which we call it the black water, is coming to our cleaning system first and to underground tanks. We have 1,000, 5,000 of the wastewater tanks under the laboratory. Then there is the special company who are arriving, taking all these bad things from us.
You were ready for this question, right?
Yes.
All right. Any other questions? Vēl kāds jautājums? Yeah. Thank you for a fascinating lecture.
Thank you very much.
Paldies.
Thank you.